Hello, good morning. Good morning, all. Hello, students. How are you? Hope you are safe at home and also you are studying at home. And hope all of you are enjoying my lectures. So, dear students, yesterday I have sent one link of app. I will explain in detail about that app very soon, and afterwards we will conduct our lectures on that app. We will conduct some lectures on app and some lectures here on YouTube. Okay, so many students are unable to yet unable to download and use that app. So we are conducting some lectures on YouTube. After almost all the students are there, many students are there. Then we can conduct the classes on app. The features of app are there. You can give you can watch the live sessions or you can watch the recorded videos. There you can have the assignments. I will daily give the assignments and you can also give the test. The parents can view the results of their works. So many features are there, but as it is beginning, I have not added more content in that. So soon in 1 or 2 days, the app will be in full pledged. Okay, now without wasting more time, hi now every hello. There is some problem regarding the network connections. If there is network failure, uh, I will try to reconnect and the class will be resumed. So wait for few seconds or few minutes to resume the session. Okay, hello everyone. Once again, welcome to all, and let us now move to the our actual content. I was telling that we will be conducting our lectures on app also and on YouTube also. I expect or I think many students from Maharashtra or from India or from world all are at home and all can be benefited with my lectures. It is not restricted to only our city. So I will be publishing the videos on YouTube also. But the assignments, the tests will be for the students of class only. Some network problem is there. See now the problems from limits. Today we are going to see the exercise 7.4. So here are the problems from exercise 7.4. Yesterday we have seen some important theorems where such as limit of sine theta upon theta, very important theorem, as theta tends to 0 equals to 1, where theta is in radians. Okay, so this was the theorem which we have seen yesterday and some corollaries. So very important is this theorem. This is very important theorem, and using this theorem only we are going to solve the today's problems. Okay, some corollaries also we have discussed, but all the corollaries depends on this theorem. And today also we are going to see the problems based on this theorem. Okay, let us consider the first example. First of all, call this as L. I will denote this by L. Limit as theta tends to 0 of sine of m theta divided by tan of n theta. Okay, to obtain the standard form. What is the standard form? Whenever there is some angle x with the sine function, then x must be in the denominator. As x tends to 0, then I can write its limits to be 1. We can use the corollaries also, but at the beginning I will explain in detail the basic solutions. So to obtain this form, I will divide the numerator and denominator by theta. Multiple is different. As this multiple is different, I cannot divide by the different multiples. And so I will first divide the numerator and denominator by theta. This complete divided by tan of n theta upon theta. Okay, now we can take the separate limit. Take the limit of numerator separately and the denominator separately. We have divided the numerator and denominator by theta, and now I will take the separate limit. Separate limit घेऊ शकतो आपण. We know that limit of quotient is equal to quotient of their limits provided the limit in the denominator is a non-zero. So this complete divided by limit of tan of n theta upon theta. Theta tends to 0. Okay. Now yesterday I have told some corollaries, and if we use these corollaries, then you can write the answer at this step only. We have seen the corollary of this. That was this one. Limit of, here I have written, limit of tan px upon x tends to 0 is p. Also I have told you that limit of sine of px upon x tends to 0 is equals to p. Variable may be anything. Means you may have theta here, you may have x or z or anything you want. So sine of px upon x tends to 0 is p. Using this corollary, I can write the limit of numerator to be m and the limit of denominator to be n, and that is your answer. That is your answer, m by n. We have seen this corollary. Or if you want to write in the standard form, then also you can have the standard form like this. You may adjust here more here, limit theta tends to 0. This is your answer now, m by n. But if you want the more details here, you can write like this also. Sine of m theta. Now multiply this denominator by m and the numerator also by m, like this. This complete divided by limit of tan of n theta as theta tends to 0 upon multiply this by n like this, n theta into n. And we know that the limit of this term is 1. Now if I call this as x, sine x upon x and x tends to 0 is there. जर हा theta tends to 0 असेल, if this theta tends to 0, then I can say that this m theta also tends to 0. If this theta tends to 0, then this m theta also tends to 0. So if I call this as x, then sin x upon x tends to 0, which is 1. So in this case, the limit will be 1 into m. In the same way, the limit of this quantity will be 1 into n, and you will get again the answer as m by n. Okay, now let us move further for next example. Sorry. Now let us see the second example. First of all, call L. L is equals to limit as very easy, theta tends to 0. Dear students, remember that you must know the identities from trigonometric functions, trigonometric ratios. There are so many formulas in trigonometry which we have studied before, and so we have to remember those to solve the trigonometric limits. We know the formulas from the trigonometry. So we know the formula for 1 minus cos 2 theta. So it is equals to 2 sine square theta. 1 minus cos 2 theta is 2 sine square theta. So remember this formula, and if I use it here, I will get theta tends to 0. Now this 1 minus cos 2 theta is nothing but 2 sine square theta, and this complete divided by theta square. Okay, 1 minus cos theta formula is known to me. So this 2 is in multiplication, and using the result limit of k into f of x, as x tends to anything, is equals to k into limit of f of x, x tends to a, means k can be taken outside. If k is in multiplication, then it can be taken outside, means this 2 can be taken outside. 2 into limit of theta tends to 0 of sine square theta upon theta square. One more result is there, which we have not seen in the theorems, but I will write here, which we are going to use now in the next step. There is one more theorem. If there is a composite function, means like this, limit of f of g of x as x tends to a, it is equals to f of limit of g of x, means if there is a limit of composite function, then you may find the limit of first function and then apply the second function directly to the limit of first. Means in this case, now this is a composite. Here I can write this as limit theta tends to 0. This function can be written as sine theta upon theta whole square. This is a composite. First function is sine theta upon theta, and the second function is this. So using this result, I can write as 2 into, firstly take the limit of first function, which is in this case sine theta upon theta, and then apply the second function, which is a square, like this. Very easy. So this is equals to 2 in bracket 1 whole square, it is equals to 2. So this is one more result, you should note it. Remember the formulas from trigonometry. Okay, good morning everyone. Udita is there. Do attend the classes regularly. Now let us see now the third example. तिसरा एक्झाम्पल पाहूया आपण. हे सर्व एक्झाम्पल्स आपल्याला पुढे लागणार आहेत, लक्षात घ्या. See now the third example. Let L is equals to limit as x tends to 0, x tan x divided by 1 minus cos x. This one. Now there are two different ways for solving this. I would like to introduce one more corollary which is not stated in our textbook. If we use the corollaries, the problems becomes easy and shorter. For competitive type exams, we have to reduce the length of the solution and we have to reduce the time also. So step by step, I am moving towards the problems which will take less time, or I will explain the methods which will take less time. Now, before going to the solution of this problem, I will explain one corollary here, and in future problems, in further problems, we will use this corollary directly. Okay. So the corollary is like this: limit of 1 minus cos x upon x square. Note this corollary. This is not stated there in the textbook, but this is very useful. If you remember this, the problem becomes very easy. So 1 minus cos x upon x square, x tends to 0 is 1 by 2. Okay, so this is the corollary. If you want, I can prove this here. I will prove this corollary and then we will go to the move to the solution of this one. So this limit can be calculated like this. Here I am going to prove this corollary. Limit x tends to 0. 1 minus cos x is known to you. The formula for 1 minus cos x is 2 sine square x by 2. Different methods are there, of which I am going to use one here. 1 minus cos x is 2 sine square x by 2. This is your 2 sine square x by 2. This complete divided by x square. I am finding the limit of this is equals to, this 2 can be taken outside because it is a constant in multiplication, and these two square terms can be combined in one bracket like this: sine of x by 2 upon x whole square. Now this can be written as 2 into limit x tends to 0 of sine of x by 2 means half x upon x and this bracket square like this. It is equals to. Now using the previous corollary, which one? Sorry. Now using this corollary, sin px upon x, x tends to 0. Sorry, it is not there. Limit of this corollary, sine of px upon x, x tends to 0, it is equals to p. This one, sine of px, x tends to 0 is equals to p. So inside the bracket, now your p is nothing but 1 by 2. Sine of px upon x. Sine of, I'm calling this as p. 1 by 2 as p. Sine of px upon x. X tends to 0 is p, means in this case it is 1 by 2 whole square. So how much is that? 2 into 1 by 4? It is nothing but 1 by 2. So remember this: 1 minus cos x upon x square. 1 minus cos x upon x square. X tends to 0 equals to 1 by 2. So if I remember this corollary, this problem becomes very easy. So whenever there is a term of this kind, 1 minus cos x in the denominator, and it becomes 0 and putting the value of x, then you should think of this corollary. In this case, x tends to 0 is must. 1 minus cos x upon x square. If it is x tends to 0, then the limit is 1 by 2. So I should think I should divide the numerator and denominator by x square. अंशाला आणि छेदाला तुम्हाला काय करायचंय? x square ने divide करायचे. Okay, so divide by x square. X tan x upon x square. Divide the numerator by x square and also divide the denominator by x square. Okay, because I want to use this. Okay, now this is equals to, the problem is almost completed. X tends to 0. In the numerator, 1x can be cancelled and I will get tan x upon x, x tends to 0. This complete divided by limit of 1 minus cos x upon x square, x tends to 0. And is finally the numerator limit is 1, we have written that, and the denominator limit is 1 by 2, and 1 upon 1 by 2 is simply 2 is the correct answer. Okay. Now let us move further. The next question. See this third example. It is very easy now. I think we have seen third. Now let us see the fourth one. Let L is equals to limit x tends to 0 sec x minus 1 divided by x square. It is again based on the same corollary which we have used in the previous example. Now this sec x can be written as 1 by cos x minus 1 is divided by x square. Now just multiply the numerator and denominator by cos x. Multiply the numerator by cos x and the denominator also by cos. So if I multiply the first term by cos, cos upon cos will get cancelled, you will get 1. Minus again if I multiply this by cos, I will get cos x. Also multiply the denominator by cos x like this. Okay, now I know the limit of this term which we have seen in the previous example. The limit of this term is 1 by 2, and limit of this 1 upon cos x as x tends to 0 is nothing but 1 upon cos 0, and cos 0 is 1, and so my answer is 1 by 2. Whenever some term is non-zero, then I can directly put the value of x. If it is non-zero by putting the value of x, then I can use the direct method. Okay, so that is answer 1 by 2. Now let us move for next type. Here is the second type now. Now I am using some tricks. As I am using the corollaries, it means I am using the tricks because the detailed solutions are more lengthy. Step by step, I'm moving towards the tricks, but still more tricks are remaining, and we will consider those after completion of this chapter. Now let us see. One more corollary I want to write here for the solution of this problem. Type 2, first question. Let L is equals to limit x tends to 0 1 minus cos nx divided by 1 minus cos mx. If you remember the corollary, then you can solve these problems very easily. I'd like to write one corollary here again. Limit of 1 minus cos of kx upon x square x tends to 0 is equal to k square by 2. Very easy. Again, you can have the proof of this, and if you don't want the proof, you can remember this as a corollary. But still, I will explain the proof of this corollary. And if you remember this corollary, this problem can be solved in 5 or 10 seconds. In very few time, this problem can be solved if you know this corollary. Let us see the proof of this corollary first. Let us see the proof. The numerator can be written as using the formula for 1 minus cos theta. Formula for 1 minus cos theta is 2 into sin square theta by 2. 1 minus cos theta kya hai? It is 2 sin square theta by 2. Remember this formula. 1 minus cos theta is 2 sin square theta by 2. So in this case, I am calling this kx as theta. मी या kx ला theta म्हणतोय. So 1 minus cos of theta. 1 minus cos of theta. What is it? 2 sin square theta by 2. 2 sin square theta by 2 means it is kx by 2. Theta by 2 किती आहे त्या ठिकाणी? Kx by 2. This complete divided by x square. Okay. 1 minus cos theta is 2 sin square theta by 2. In present corollary, theta is nothing but kx. Okay. Once again, this 2 can be taken outside because it is in multiplication. Take that 2 outside and we have limit x tends to 0. Now the square term and this square term can be combined together to give you sine of, I will write this kx by 2 as k by 2x upon x and this square as it is. A square, common square. Now use that corollary which we have used in the previous one. Which corollary? Limit of sine px upon x tends to 0 equals to p. This is the corollary. So using this corollary in this problem, p is nothing but k by 2. Sine of px upon x. So the limit is p. P means in this case k by 2 whole square. So what I am getting here? K square by 4 into 2 means it is simply k square by 2. So remember that limit of 1 minus cos of kx upon x square, x tends to 0 is simply k square by 2. So in present problem, if I divide the numerator and denominator by x square, I can get the form of this corollary. Okay, so I will divide the numerator by x square and denominator also by x square. अंशाला आणि छेदाला x square ने भाग द्यायचा आहे. Okay, this complete divided by 1 minus cos mx upon x square. वर खाली आपण काय केलंय? x square ने भाग दिलेला आहे. Now we know the corollary for this. 1 minus cos kx upon x square. Now in this case, k is nothing but n. 1 minus cos of kx upon x square means k square by 2. So here it is n square by 2. And in the denominator also it is m square by 2. So this 2 and 2 will get cancelled and we are left with the answer n square upon m square as the correct answer. ठीक आहे. हे डाउट्स असतील तर तुम्ही पोस्ट करू शकता. मी हळूहळू सांगतोय, प्रत्येक गोष्ट बेसिक लेवलवर सांगतोय. Okay, now let us move further for the second example. See this one, second now. Let L is equals to, firstly call this as L. Let capital L is equals to limit x tends to pi by 6 is there. 2 minus cosec x divided by, initially I have told you that you have to check what happens to the denominator. Means if I directly put the value of x and if the denominator is non-vanishing or non-zero, in that case we can put the value of x directly. But if it is 0, then you have to go for the simplification. You may simplify using factorization. You may simplify by using rationalization. In case of trigonometric limits or in case of trigonometric functions, we have to use the trigonometric identities for simplification purpose. So, to simplify this expression, firstly observe what happens to the denominator. If I put x equals to pi by 6, in the denominator, I will get cot square pi by 6 minus 3. What is the value of cot pi by 6? It is root 3. Cot pi by 6 is root 3 and its square is 3. So 3 minus 3, it will be 0. Means the denominator is becoming 0 and numerator also becoming 0. If I put x equal to pi by 6 here, cosec pi by 6 is 2 and 2 minus 2 is 0. Means the numerator and denominator are both becoming 0. That means there must be some common factor which can be cancelled. So I'd like to obtain a common factor which is present in numerator as well as in the denominator. So to find that common factor, there should be some common functions. Now, you know the formula for cot square. You know the fundamental identity for cot square. And the cot square x is nothing but cosec square x minus 1. You know this thing. 1 plus cot square x is cosec square. And from which cot square can be written as cosec square minus 1. If I write this cot square in terms of cosec square, there is the possibility of getting common because there is a cosec in the numerator. Okay. So first of all, write that cot square x in terms of cosec square x. Okay. So x tends to pi by 6. This 2 minus cosec x. This complete divided by cot square ला आपण लिहू शकतो cosec square x minus 1 cot square, the formula for cot square, this minus 3 as it is. Okay, that is further equal to limit, very easy problem, x tends to pi by 6, this 2 minus cosec x as it is, and in the denominator it is cosec square x minus 4, cosec square x minus 4, which can be factorized. The denominator is cosec square x minus 4. This 4 can be written as 2 square, and then it can be factorized using a square minus b square as in one bracket a minus b, in another bracket a plus b. So I'll directly write the denominator as cosec x minus 2 in one bracket and into cosec x plus 2 another bracket. Now you can observe that this term, the numerator, and the first bracket in the denominator are negatives of each other. They are the negatives of each other, and therefore their ratio will be minus 1. Or instead you can write the numerator by taking minus 1 as a common. So in bracket it will be cosec x minus 2. So in the latter step you can cancel cosec x minus 2. So the denominator as it is cosec x minus 2 and this bracket cosec x plus 2 as it is. Okay, now very easy. So this is equals to further x tends to pi by 6 minus as it is. Don't forget the bracket get cancels. Cosec minus 2 and this get cancels, and we are simply left with 1 upon cosec x plus 2 with minus sign. And if I now put the value of x to be pi by 6 here, cosec pi by 6. What is cosec pi by 6? 2. Remember, when I put the value of x, then there is no need to write this limit because the process is completed. The process of finding the limit is completed. In that case, you should not write this word limit. So this is equal to minus 1 by 4 is the correct answer of this problem. Okay. Okay, welcome all. अपेक्षित आहे सर्वांना समजतंय. मी जाणीवपूर्वक इंग्लिश मधून शिकवतोय की जर इतरही कोणी पाहिलं तर त्यांनाही समजावं, आणि जर नाही समजलं तर ते काय करतात, उलटे अंगठे दाखवतात, जे की मला आवडत नाही. ना दाखवू द्या, पण मी आय एम डेलिबरेटली टीचिंग इन इंग्लिश और I may teach in Hindi. Okay, see now the next and the last from this type. This is equals to third one. Let capital L is equals to limit x tends to fiber of cos x minus sin x, this complete divided by cos of 2x. Very easy, very easy, because we have a formula. So you might have observed up till now that the formulas from trigonometry are very important. This is just the beginning, and we need almost all the problems formulas from 11th standard which we have studied. So the formulas are very important. Try to memorize those formulas. Now formula for cos 2x is known to you. Firstly check whether the denominator is becoming 0. Now in this case also the denominator becomes 0. If I put x equals to pi by 4, the denominator will be cos of pi by 2 means 0. So the denominator is becoming 0. That means I must find a common factor in the numerator and denominator. So try to express this cos 2x so that it will contain a term in the numerator. And we know the formula for cos 2x in terms of cos and sine, which is equal to cos square x minus sin square x. Formula part पाहिजे मला cos 2x is cos square x minus sin square x. Again factorize this. याचे factors घेता येतील मला. The factors are cos x minus sin x in one bracket and another bracket is cos x plus sin x. I may directly write the denominator like this. Cos 2x is known to you. So factorizing that, I can write the denominator as x tends to pi by 4. This cos x minus sin x as it is. And cos 2x is cos square minus sin square and can be factorized like this. I will write directly here. Cos x minus sin x into another bracket cos x plus sin x. Now from numerator and denominator, a common term can be cancelled, which is nothing but cos minus sin. So we are simply left with 1 upon this and then put the value of x to be pi by 4 and you will get here cos pi by 4 plus sin pi by 4. As the denominator is non-zero in this case, we can put the value directly. So we have 1 upon cos pi by 4 is in this case it is 1 by root 2 and sin pi by 4 is also 1 by root 2. So this is equals to 1 by root 2 plus 1 by root 2. It is nothing but 2 by root 2 and 2 by root 2 is nothing but root 2. You can simplify by yourself. So I had added these two 1 by root 2 plus 1 by root 2 same terms means it is 2 times of 1 by root 2. 2 times of 1 by root 2 means 2 into 1 by root 2 and which is nothing but root 2. So that is in the denominator. No, this one as it is in the numerator and the sum of these two terms is nothing but root 2. Okay. Now let us move further for the next type of problems. So this is now type 3. This is the type 3 problems. Let us consider now the first one. Let L is equals to limit as x tends to 0 is there. Whenever there is x tends to 0, we can think of the standard formula 1 cos ax minus cos bx divided by cos cx minus 1. So cos cx minus 1, the corollary must be strictly here. So you must know the corollary limit of 1 minus cos of kx. Just before I have given the proof of this corollary, and if you remember this corollary, this problem becomes 0. This problem becomes easy. Without this corollary, the problem will become lengthy. Okay, so 1 minus cos kx upon x square, x tends to 0 is equals to k square by 2. ठीक आहे. So denominator मध्ये मला हा फॉर्मॅट आणता येईल. In the denominator I can adjust this 1 minus cos of cx very easily and also in the numerator I can adjust it. Just I need 1 in the numerator, 1 minus something. So I will try to adjust the terms in the numerator in this form. Let us see how. X tends to 0 cos of, I will adjust ax minus 1. This minus 1 is the extra term. I want 1 minus. I will then take minus 1 common. So this minus 1 is extra. So I should cancel it by adding plus 1. And this remaining term minus cos of bx as it is. This complete divided by the denominator also as it is. Cos of cx minus 1. Now try to express in this form 1 minus cos kx. So first two terms in the numerator can be written as negative of 1 minus cos of ax. I have taken minus 1 common. I have taken minus 1 common from these two terms. So if I take minus 1 common, the signs will be reversed. And the next term as it is 1 minus cos bx as it is. And in the denominator also, I will take minus 1 as a common, and so bracket remains 1 minus cos of cx. Now simply divide. To obtain or to use this corollary, there should be x square in the denominator. This is the standard form of the corollary. There must be x square. Then only I can use this corollary. So divide to each term by x square. To each term in the numerator by x square and in the denominator also by x square. So you will get 1 minus cos ax upon x square. Nextly also 1 minus cos of bx upon x square, and this complete divided by negative in bracket 1 minus cos of cx divided by x square. We got this simple solution. Let us move further. Now using this corollary, I will write the answer. I'll write now the answer using this. So what will be the first limit in this case? Limit of this minus sign as it is. First minus sign as it is. 1 minus cos ax upon x square. Using this is k square by 2, means in this case it is a square by 2. Plus for the second term also it is b square by 2 using the same corollary. And this complete divided by the minus c square by 2. Simply use this corollary repeatedly. 1 minus cos ax upon x square is a square by 2. 1 minus cos kx upon x square is k square by 2. Okay, so that is equal to multiply to each term in the numerator and denominator by minus 2. I'd like to make this first term to be positive, so I will multiply by minus also and by 2. So if I multiply by minus 2, I will get a square minus b square upon c square as the answer. This is the simple solution. There is another method also, but we will see it later. But this one is the simple method. Up till now, from the concepts which we have studied, this is the easiest way for solving this problem. Hope all of you are getting this. Okay, let us see now one more example, and then later I will give two problems for homework. Last problem for today. The last problem for today, and then these two are the homework for you. You can submit the homework on WhatsApp, or also you can submit it on the app also. Let us see now this one. Let L is equals to x tends to 0 of in bracket under root of this 1 minus cos x minus root 2 as it is, this complete divided by sine square x. Okay, now the denominator becomes 0. If I put x to be 0 in the denominator, it is becoming 0. That means I must go for the simplification. I must go for the simplification, because the denominator is becoming 0, and also if we put x equal to 0 here, I think there is some correction. This limit doesn't exist. There is a correction. If you observe, the denominator is becoming 0. Sorry. It is x tends to pi is there. Instead of this 0, it is pi is there. You can observe this. It is pi. Mistakenly I have written 0. It is pi. X tends to pi. Okay. Dupevar. I like such type of suggestions because it proves that you are observing or you are watching very carefully. So you must suggest if I am making some mistakes there. So this is equals to now. Now x tends to pi means sin pi is 0, means the denominator is becoming 0. And if I put x equals to pi here, cos pi is minus 1. So 1 minus minus 1 means it is plus 2. Root 2 minus root 2. The numerator is becoming 0 and the denominator is also becoming 0. To simplify this, I have to rationalize the numerator. So after rationalization, what I get? After rationalization, I will get the square of first means 1 minus cos x minus the square of second means the square of root 2 is 2. I just rationalize the numerator and I should write the conjugate in the denominator. If we have to rationalize the numerator, then I should write its conjugate in the denominator also like this. Okay, root 2. Very easy problem. And this is now equals to limit x tends to pi. Okay, x tends to pi in bracket is 1 minus 2. 1 minus 2 is minus 1. This minus cos x. I must cancel some common term that is becoming 0. ज्याच्यामुळे डिनॉमिनेटर 0 होतोय ती टर्म कॅन्सल करणं आवश्यक आहे. Okay, like this. So x tends to pi. Now from the numerator minus is common. So in bracket 1 plus cos x. Okay. This complete divided by now. Sin square x can be written as 1 minus cos square x. Sin square x ला काय लिहिता येईल आपल्याला 1 minus cos square x and its factors are in one bracket 1 plus cos x into another bracket 1 minus cos x sin square x. Sin square x चा फॉर्म्युला आहे आपल्याकडे. It is 1 minus cos square x using the fundamental identity and this can be factorized using a square minus b square like this. Okay, and this term as it is. Okay, now from the numerator and denominator we can cancel this 1 plus cos x and we will get now minus 1 upon in bracket 1 minus, if I put x to be pi here, या जागी जर मी पाय ठेवला तर cos pi किती असतो -1, so this will become 1 plus 1 2 into another root of 1 minus cos pi means -1 and it will become plus 1 and this root 2 as it is. So this is the answer. Hope you got this. Root 2 plus root 2 is a 2 root 2. तर अपेक्षित आहे तुम्हाला हे समजतंय. हळूहळू आपण पुढे जातोय. जसजसा तुम्ही रिस्पॉन्स द्याल तसतसं आपल्याला आणखी कंटेंट यामध्ये वाढवता येईल. आपण जेई मेन लेवल पर्यंत ॲडव्हान्स लेवल पर्यंत सुद्धा शिकू शकतो. ही जी करोनाची अडचण आलेली आहे तिला तुम्ही अपॉर्च्युनिटी समजून जास्तीत जास्त अभ्यास करा. आपल्याकडे साधनं आहेत. ह्या साधनांचा वापर करून जसं इंटरनेट आहे, मोबाईल आहे, लॅपटॉप आहे, या साधनांचा वापर करून आपण शिकू शकतोय. संपूर्ण जगभरामध्ये, संपूर्ण भारतामध्ये सध्या ऑनलाईन एज्युकेशन, मी जर तुम्ही माझं नाव गुगल मध्ये सर्च केलं संतोष पोपडे तर तुम्हाला लक्षात येईल की मी 2007-8 पासून या ऑनलाईन एज्युकेशन बद्दल बोलायचो की ही जगाची गरज होईल की चांगले टीचर्स ची संख्या वरचीवर कमी होते आणि त्यामुळे ऑनलाईन एज्युकेशन हा एक पर्याय खूप फायद्याचा ठरू शकतो असं मी खूप दिवसापासून मागच्या माझ्या 20-21 वर्षाच्या अनुभवामध्ये मी हे पाहिलं की हे खूप चांगलं माध्यम आहे. जे लोक स्वतःच्या शिस्तीने शिकू शकतात अशांसाठी ऑनलाईन एज्युकेशन हे खूप छान आहे. पण विद्यार्थी मित्रांनो लक्षात घ्या की या कोरोनाच्या संकटात खूप ऑनलाईन क्लासेस सुरू झालेले आहेत. वेगवेगळ्या प्रकारचे आमिष दाखवतात, पैसे घेतात आणि मग त्यातून फसवणूक होण्याची शक्यता सुद्धा असते. सो कुठलंही ऑनलाईन क्लास जॉईन करण्यापूर्वी त्याची संपूर्ण माहिती असल्याशिवाय तो जॉईन करू नका. कारण जॉईन केला, पैसे भरल्यानंतर जर तो क्लास कंटिन्यू चालू नाही राहिला तर अडचणी येऊ शकतात. सो बी केअरफुल बिफोर जॉइनिंग द ऑनलाईन क्लासेस फ्रॉम अदर सिटीज ऑर फ्रॉम एनीवेअर, बट बी केअरफुल. हे माझे तुम्हाला, माझे विद्यार्थी म्हणून सांगणं एक कर्तव्य ठरतं. सो बी केअरफुल. आपण जवळपास सगळे जे चॅप्टर्स आहेत, जितके दिवस लॉकडाऊन चालेल तितके दिवस आपण रेग्युलरली हा क्लास घेणार आहोत. भविष्यामध्ये आवश्यकता पडली तर आपण वेळेचे सुद्धा बदल करणार आहोत. आणि वेळ जरी ऍडजस्ट नाही झाला तर याच्यात आणखी एक फायदा हा असतो की हे लेक्चर्स रेकॉर्डेड राहतात, म्हणजे तुम्ही तुमच्या सोयीनुसार त्याला कितीही वेळ पाहू शकता. ओके, थँक्यू व्यंकटेश, थँक्यू प्रांजली. ओके, थँक्यू, थँक्यू ऑल. ॲपमध्ये ज्या मी सूचना देतोय वारंवार त्या तुम्ही पाहत राहा. आजचे जे होमवर्कचे प्रॉब्लेम्स आहेत हे तुम्ही घरी सोडवा. हे तुम्ही व्हॉट्सॲपवर पाठवणं आवश्यक आहे, कंटाळा करू नका. जितका रिस्पॉन्स तुम्ही द्याल तितक्या डेव्हलपमेंट्स आपल्या क्लासमध्ये होतील. आणि जर तुम्ही आळशी राहिलात तर मला सुद्धा खूप जास्त उत्साह येणार नाही. सो दिलेले होमवर्कचे प्रॉब्लेम सोडवत जा. काही शंका आल्या तर विचारत जा. तुम्ही तुमच्या शंका पोस्ट करत जा, त्या योग्य वेळेवर तुमच्यापर्यंत वापस येतील. ॲपमध्ये सुद्धा तुम्ही असाइनमेंट जो सेक्शन आहे त्या ठिकाणी हे होमवर्कचे प्रॉब्लेम्स पाठवू शकता. लवकरच आपण याच्यावर एक टेस्ट पण घेणार आहोत, ऑनलाईन टेस्ट, जे की MCQ पॅटर्नची असेल. आणि असाइनमेंट्स ह्या आपल्याला डिस्क्रिप्टिव्ह टाईपच्या, सब्जेक्टिव्ह टाईपच्या असतील. थँक्यू, 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 थँक्यू फॉर ऑल. ओके, तर आपण इथे थांबूया. प्रत्येकाने थँक्यू, थँक्यू उदिता, अक्षता, अनिश, प्रणिता. सो सगळ्यांनी होमवर्क करा.